So today in the fourth video of unit number 6, we're going to talk about potential energy. So we just talked about kinetic energy after talking about work and power. So potential energy is quite different from kinetic energy in how we think about it, because it encompasses a lot more than just the energy of movement. So potential energy is the energy, anything that is energy that is stored. Another way you can think about it is that it can, doesn't mean it is, but it has the potential to do work. So there's something stored in it somehow. So there's many different examples, but some of them are elastic and chemical, nuclear, and gravitational. Gravitational are all different examples. There's lots of different ways to store energy. Each of them has their own purpose and is often used in a lot of different engineering places. So we're actually going to only deal with gravitational potential energy. Energy dealing with your position relative to something else. So it's just due to a position. So the formula for this is E, standing for energy, and we're going to give it G to stand for gravitational potential, and mg times h. Now there's going to be, you can find derivations of this. I'm just giving you the formula. You might see in different places in textbooks or online, you might see this standing as a potential energy, or you might see the symbol as EP, or in advanced physics you might actually see potential energy given the symbol of a capital U. So they're all just different symbols meaning the same thing, potential energy. So just keep that in mind. You don't always see EG, it can change. Units of potential energy, units of all energy is joules, and so we have mass times gravity times the height of the object. Now, this only applies to objects on the Earth's surface because we're using the value of g, which makes sense because g does change if we get too far away from the surface. And then, just like kinetic energy, if you change your potential, you've done work. So we can have the same relationship as the work is equal to the change in potential, which, very similar to how we used it before. But the first question is, can you have a zero potential? Now this is an important idea, and absolutely, but not always. But also all the time you can. So it's very dependent, and it depends on your reference point. So if I have two buildings that are for all intents and purposes the same, if I defined in this one that this is 0 meters and I said that it is 20 meters tall, that's fine. Our reference point is the bottom. And if we're thinking about our potential energy at the bottom, it would be 0 because our height is 0. But you can equally, and it is completely valid, to say that the top of it would be our reference point and make that 0 meters, which would make the bottom of it negative 20 meters. And so the potential energy in this situation would be 0 at the top. But it doesn't ever matter where your reference point is, because 99.99% of the time we're actually going to be using the change in energy. And so you can do all kinds of calculations, but the change in energy doesn't depend on your reference point. Just the individual energies do. But the change, as long as the reference point is the same in both situations, will always work out to be the same, which is kind of cool. So let's take a look at this example where we're lifting a bowling ball 7.30 kilograms from the storage rack up to your shoulder. Storage rack is 0.61 meters off the floor, and your shoulder is 1.12 meters off above the floor. So part A is when the bowling ball is at your shoulder, what is the bowling ball's gravitational potential energy? So how much work could it do if you dropped it? So we're looking for EG, and so mgh, we have to think about what height we're using. We want to use the bowling ball's height when it's at your shoulder above the floor. So we're going to have its mass, 7.30 kilograms, times 9.80 meters per second squared, times the height of your shoulder, which is 1.12 meters, and that, with 3 sig figs based on our values, is going to be 80.1 joules. Okay, great. Off to a good start. Now let's do part B. When the bowling ball is at your shoulder, so okay, it's at the same spot, hasn't moved. What is the bowling ball's gravitational potential energy relative to the storage rack? So right now we only know the height of went from the shoulder to the floor. So first off, we need to know this height, and it's going to be the height of your shoulder minus the height of the storage rack, which will give us 0.51 meters. So 1.12 meters minus 0.610 meters gives us, to proper sig figs, 0.51. So now we can just go into our EG is mgh, because our different reference point, and then we're going to go for 7.30 kilograms times 9.80 meters per second squared times 0.51 meters, because that's how high it is above our reference point, and that's going to give us 36 joules. Now the sig figs are different because 0.51 ends up being 2 sig figs instead of 3, so we end up with 2 sig figs in this one. And part C asks us for how much work was done by gravity if you lifted the ball from the rack to your shoulder. So if we were going to look at part C, we would know the work done is our change in energy. In this case, we're doing change in EG, so our change in potential energy. So we're looking at the change from the rack to the shoulder. So if we think about our final energy, would be the potential energy at the shoulder level. So energy G at S minus the energy of potential G at the rack. Now I'm going to use the reference point to be the floor because both of our heights are given from the floor, but if you could choose the reference point to be the shoulder or the rack, and you will get the same answer as long as you calculate the heights properly. So, if you're curious, go ahead and do that, but I'm just going to do it from the floor, which gives us, so mg height of the shoulder minus mg height of the rack, which you could plug those numbers in. I'm not going to show it, and you will get, to proper sig figs, an answer of 44 joules for the work done. So we've got our 3 answers there to the question, and all about potential energy. So that's one example. Again, always work on the same thing. Write out your givens, find your equation, and just see where it leads you. If you get stuck, see if you can connect a different equation. Try out those examples, and as always, physics is awesome.